Now in 3.3 we are going to talk about properties of logs. And I wrote these down. The product property is the log base b. If the two arguments are multiplied together, remember logs are exponents, and when you have the same base and you multiply two items that have the same base, you add the exponents. The quotient rule is just similar to the exponential rule. If you have the same base and you divide the arguments, you're going to subtract the exponents. And the power rule is where you have a log base b of x to the n, you're going to take and bring the n in front and multiply the exponents. Now I wrote down the basic properties that we had from 3.2 because you're going to use not only these properties, the product, quotient, and power rules, but you're also going to use these basic properties. Now in an example 1, we have log 96 and we want to express it in terms of log 2 and log 3. So the first thing I'm going to do is I'm going to take 96 and I'm going to divide it by 3. And when I do that, I get 32. So now I have where 96 equals 2 to the 5th times 3. So now I've got the in terms of log 2 and log 3. And I'm going to rewrite this. I've got log 96, and it is going to be equal to the log of 2 to the 5th times 3. I can then rewrite this using my product and then my power rule. So I've got log base, or log 2 to the 5th plus log 3. And I'm going to write the power rule, log 2 plus log 3. So now I have changed log 96 to be equal to this expansion. Now we're going to do the same thing with this one. We know that log 32 over 9 is the same thing as writing log 2 to the 5th over 3 squared. Now I'm going to take this in steps. I'm going to use the quotient rule, which is 2 to the 5th minus log 3 squared. And now I'm going to use the power rule, which says I bring the exponent in front, minus 2 log 3. So now I've got that expanded. How am I going to evaluate this one? I'm going to rewrite it, log base 2, and I'm going to say 2 to the 5th raised to the 1/3 power. Now I'm going to actually say, okay, what have I got here? I'm going to multiply the exponents, log base 2, 2 to the 5/3. Now I can take the 5/3, bring it in front, and write log 2, 2. Our basic property says that log 2, 2 equals 1, so I have now evaluated this without a calculator and gotten 5/3. All right, let's look at this one. I'm going to evaluate this. Remember, this is base E. So I could actually use the properties and say, well, let me bring this 4 in front, and now I have 3lne, and I'm going to take and put the 2 in front, and now I have 2lne. And remember, the natural log of e is just 1. So now I have 4 times 3 times 1 minus 2 times 2 times 1. So I have 12 minus 4, which is 8. Now you could have things like this on the exam without calculator. Okay, now we're going to expand these. Before we were taking them, well, we were evaluating it. Now we're just going to expand these. We don't know what m and n equal, but we're going to use the rules that we had before. So if I take this, these are all multiplied. I can rewrite it as ln4 plus ln m to the 3rd plus ln n to the 5th. And now I can use the power rule. ln4 plus 3 ln m plus 5 ln n. And now it's expanded. I'm going to do the same thing down here, but I'm going to rewrite it. I'm going to actually say log 2x minus 3, and I'm going to rewrite it as 3x to the 1/4. Now when I've got this, this is a division. So what I'm going to write is log 2x minus 3 minus log 3x to the 1/4. This is all one argument. I can do nothing else with this one, so I'm just going to rewrite it. 2x minus 3. But I'm going to expand this. This is minus log 3. Now usually when they're multiplied, I could actually put this and put plus log x to the 1/4. Because this is minus the whole thing. I'll rewrite it again. And I've got 2x minus 3 minus log 3 minus 1/4 log x. And I've now expanded it. Now if we can expand, we also have to learn to condense, and these properties do go back and forth. So what I'm going to do is I'm going to write log 4, and if this is in front, I'm going to now put it back here, minus log 4 x minus 2, and I'll put the power back up here. Now we have a minus. A minus, notice these are the same base. They have to be able to do this. So now I've got log 4 x to the 1/2 all over x minus 2 cubed. Now if I wanted to, I could rewrite this. It's not necessary, but if I wanted to, I could rewrite it as the square root of x divided by x minus 2 cubed. Now we're going to condense this one, again using those same properties. If there are numbers in front, I can raise it to a power plus ln x to the 6, and if these are added, that must mean that the arguments were multiplied. And so now this is what I have, and I'm done. Now there's one more property we need to learn. It's called the change of base formula. And basically a, b, and x are positive real numbers, and a and b can't be 1. So regardless of what the base is, I should be able to use a ratio of logs to evaluate any log. Now I realize some of your calculators are able to do this, but you will have portions of your quiz, test, exam that is no calculator. So you need to know this. The way I remember it is that it's the log of the argument over the log of the base. The base goes in the bottom, or you could say the base goes in the basement. So now what I'm going to do is evaluate this one. And I'm going to use common logs. I don't have to. I could use natural logs, but our calculator actually has both of those buttons. I could write log 4 over log 6. And when I punch that into my calculator, I get approximately 0.77. Or I could do natural log of 4 over natural log of 6, and I will get the same answer. Does that mean that the log of 4 equals the natural log of 4? No, it does not. However, these ratios are equal regardless of the base that you use. So now we're going to use, again, I can't punch this into my calculator because I don't have a log base 1/3. So I'm just going to do log 8, the argument, and the base goes in the basement. And when I punch that into my calculator, I'm going to get a negative 1.89. What do I mean by punching it into my calculator? Well, let's see. What I'm going to do is I'm going to push the log button, and I'll put 8. Then I have to push the log button again, and I'm going to put 1 divided by 3, and I get negative 1.89. For those of you who are a little skeptical, I'm going to do the same thing with the natural log, divided by the natural log of 1 divided by 3. And I will get the same exact number. Okay, we're going to do an actual word problem, and I'm going to read this to you. Use the change of base formula. It's an ecology problem. Diversity in a certain ecological environment containing 2 different species is modeled by this function. Notice you have logs of base 2. N1 and N2 are the numbers of each type of species found in the sample S. And S happens to be N1 plus N2. What we want to find is the measure of diversity for environments that find 25
and 50 species in the sample.
So based on that information, I wrote down the equation, the function that they gave us, and 25 and 50. So what I have to do is I have to actually plug these in. So the diversity is going to be negative 25 over 75 log base 2 of 25 over 75 plus 50 over 75 log base 2 50 over 75. That is my equation. So I plug all these things in, and what I'm going to get is I have to use the change base formula because I don't know what this is. So we are going to write it like this: negative 25 over 75 log, common log, and I'm going to write 25 over 75 over log 2 plus 50 over 75 log 50 over 75 over log 2. Now we can put this into our calculator. Be careful of your parentheses, and we will get approximately 0.918. Now you could simplify these 1/3, 2/3, and simplify this before you plug it in, or you can let your calculator do the whole thing. And we could do the same thing by changing, we got another ecological environment, and now we have 10 and 60, and you're going to do the same thing with this 10 and 60. So S happens to be 70, and you are going to write negative 10 over 70 log base 2 10 over 70 plus 60 over 70 log base 2 60 over 70. You're going to use the change base formula. I'm just going to get rid of the zeros. Why keep carrying them? And you're going to write log 1 over 7 divided by log 2 plus 6 over 7 log 6 over 7 divided by log 2. Punch it into your calculator, and you will get 0.592. So verify that you're getting those in your calculator. Okay, the very last one is a guided practice. We have photography. In photography, exposure is the amount of light allowed to strike the film. Exposure can be adjusted by the number of stops used to take a photograph. The change in the number of stops N needed is related to the change in exposure C, and it's written as N equals log base 2 of C. How many stops would a photographer use to get 1/4 exposure? So I summarized the information here. We want to find C. So I have N equals log base C, and they tell us how many stops, or we're looking for N. So N equals something, and the exposure is 1/4. So what I have is N equals log base 2 of 1/4. Change base says I'm going to take log of 1/4 over log of 2. And when I take that, now keep in mind I could have just as easily used natural log. So I'm going to come in here, turn this on, log of 1 divided by 4 divided by log 2, and I get -2. So that means the number of stops is -2 stops. All right, we've done all the examples in the PowerPoint related to 3.3. You should be able to do your homework. I'm still only going to have the quiz on 3.1 and 3.2, and we will be talking more about 3.3 on Monday. Please have your homework done with questions ready for Monday, because we're going to also start 3.4 on Tuesday.